Alright, this video is going to be about exponential inequalities. And so with exponential inequalities, there's just a couple rules that you got to keep in mind. But I thought I'd start with a graph of an exponential function, just to kind of make sense of what we're actually doing here. So y equals 2 to the x has a horizontal asymptote at y equals 0. And then you would have a point at 0, 1, 1, 2, 2, 4, 3, 8, and it would kind of go exponential growth as such. So that's what the graph of y equals 2 to the x looks like. So in an exponential inequality today, what we're going to see something that says like solve 2 to the x is less than 3. So if I'm supposed to figure out when 2 to the x is less than 3, essentially we're figuring out from this point right here in the graph, the y value is 3, so where is the graph less than 3? And so it would be this whole part of the graph right here. And so we define it by the x value. So some x value less than, or some x less than this number would be our answer, our solution set. And so we're going to talk about what are the ways that we need to solve these things so that we can do it algebraically and don't have to look at the graph the whole time and go from there. We could also obviously have 2 to the x is greater than 5, right? And so now I'm looking at the y value of 5, and I'm looking at when are the y values greater than, and it would be this part of the graph. And so from a standpoint, that's what we're solving for, is where on these functions would it be greater than or less than these numbers. And so we're going to use logarithms to do this, and so hopefully that makes sense. Just like in solving an exponential equation, you would use logarithms. We're going to use logarithms for inequalities as well. So let's start with this one. Example 1. Right, the goal is to figure out our solution. So we want to try to get the exponential part, this thing right here. Our goal is to get that alone first before we ever use a logarithm. So I'm going to first divide by 3. And I'm going to get 2 minus 0.6 to the x is less than or equal to 1/3. And then I'm going to subtract 2. And so negative 0.6 to the x is less than or equal to, let's go with negative 5/3. And now there comes up this point that we need to remember whenever solving an inequality. Right, so whenever we solve inequalities, you must flip the symbol, right? You have to flip the symbol when you multiply or divide by a negative. By a negative. So if you look at the problem where we're at right now, we have a negative sign, but it's not being raised to the exponent. So this is actually a negative 1 in front. So we need to divide by negative 1. And as we divide by negative 1, obviously we're going to need to flip the inequality symbol. So now we're going to have 0.6 to the x is greater than or equal to 5/3. And so the question is, now what do we do? I'm going to encourage you to solve this by taking the log or the natural log of both sides. So log base 10 or natural log, because those are in your calculator pretty easily. Oops, I wanted that to be of both sides. So if you take a look, I'm just going to write it as the natural log of 0.6 to the x is greater than or equal to the natural log of 5/3. And using the power property, the x can now come out of the exponent spot and just be a coefficient. And so we would have x times the natural log of 0.6 is greater than or equal to the natural log of 5/3. So we're going to need a calculator at this point because we're going to need to get x alone. And we're going to actually divide both sides by the natural log of 0.6. Here's the key thing. You and I don't know what the natural log of 0.6 is. We definitely need a calculator to do that. And if you were to look in the calculator as to how much the natural log of 0.6 is, you would find that it's a negative number. So after plugging in natural log of 0.6, I found that this natural log of 0.6 is approximately negative 0.511. So if we're dividing by approximately negative 0.511, what do we do when we divide both sides by a negative? We flip the symbol. So our answer here is going to be x is less than or equal to, and then when you put that in your calculator, find that it's going to be negative 1. And so then from there, right, you can say, all right, if I want to write this as an interval, it would be negative infinity to negative 1 with a bracket. Okay? And so the key here is that when you take the logarithm of both sides and you divide to get x alone, if you're going to get x alone, you need to be careful when you divide that you know what you're dividing by. So you need to know that you're dividing by a negative sometimes. Maybe it's positive and you don't flip the sign, but you should use a calculator to figure out what that log actually equals before you flip any symbols. All right? Let's take a look at another one real quick. I like this one just because it's kind of fun. So if you think about it, all right, I want to take the natural log of both sides, right? So I do natural log of e to the x squared minus 4x is greater than or equal to the natural log of e to the fifth. And once again, the power property comes into play, but the natural log of e is 1. So really all you're left with is just x squared minus 4x is greater than or equal to 5. And you kind of can see that in the very beginning. You're like, okay, they're the same base. So if the bases are the same, then if the exponents are going to be different, I'm going to make sure that I want to see when that one exponent is greater than the other exponent. But now we solve it. It's a quadratic inequality, and if you need more help with quadratic inequalities, go check out my video on polynomial inequalities, and you can find that on this YouTube channel. But you need to know that you need to actually set it to 0, factor x minus 5, and then x plus 1 is greater than or equal to 0, and you have to use a number line. And so we're going to test the intervals. I've got negative 1, I've got 5, and we're going to test the intervals. So I'm going to test negative 2, I'm going to test 0, and I'm going to test 6. And all I'm doing is plugging them in to my factored form here and seeing if it makes it positive, because that's what I want. So when you plug in negative 2, you get negative 7 and negative 1 multiplied together is a positive number, so that works. Plug in 0, you get negative 5 and 1. That's a negative number when you multiply them together. That doesn't work. 6 goes in, you get 1 and 7, so it's positive, so that works. And so my answer here, right, I'll write it in interval notation, would be negative infinity to negative 1 with a bracket since we're using equal to, union, bracket, 5 to infinity. All right? And there's lots of other variations that you could have with exponential inequalities. You just got to be careful. It's pretty easy to take the log of both sides. It works. And just remember, when you're dividing, if you divide by a negative, you're going to have to flip the sign. All right? Also, if your inequality ends up, after you take the logarithm of both sides, if it ends up being something that's not linear, you're going to need to solve it most likely using a number line to test your intervals. So if it's rational or if it's quadratic or polynomial, you're going to need to use a number line, set it to 0, and solve it that way. Okay? If you have any questions, put them in the comments. And if you enjoy the video, like and subscribe. And for more wonderful math content, don't forget to hit up Mr. Yasuda's math videos. Shameless plug. Have a great day.